Okay, we're gonna load our files into Google Colab, but with Python. So first thing I want to do is make sure our runtime is in Python, and if I go all the way down to the bottom right, doesn't say anything. So it's assuming that it's Python, but I'm going to go here to runtime, change runtime, and we'll see it's Python 3. We can change to R, but it starts to limit our ability to do things, so we typically try to run in Python 3. So we're going to do, obviously, our Python coding here like this. Next thing I want to do is I want to get access to our files. So here's our Google Drive. This is the files that I have. So we've got a CSV file, we've got a JSON, and we've got a very simple JSON. And I'll show you why we've got these two different versions, because they become more complicated the more nested it becomes. So we're going to go up here, and I want to click on this. It's going to click to a runtime, and eventually it's going to allow me to get access. So I've got two options. One, I can upload a session to storage right now, and this directly puts it into this session storage. The problem with this is that as soon as we shut down the session, or if there's a hiccup or a crash, this file becomes disconnected and it no longer works. You have to upload it every single time. This will connect to our Google Drive. So I want to mount the Google Drive, connect to Google Drive. You'll have to go through your options, and eventually you might have to log in. I've already done it, so it's not going to get me to log in. And there we go. Now there's my drive. Anything that's grayed out or any of this sample data here, we don't need. But if you're looking to do some more further information, there's lots of stuff here for you to do. We're not going to use it, but we're going to go into our drive, and then we'll see my drive. Again, grayed out. We don't want any of this. We want my drive. That's my Google Drive. Mine is heavily nested here because I got a lot of work. And we're going to go to, in my case, environmental sensing, lab 3, and there's the files. All right, so I've got my files right here. That's the exact same ones that I just saw. So it's directly linked now to my Google Drive. That's what we want. And so the important part out of this now is that if I were to go to, for example, this and click on copy path, I now got a direct link to my Google Drive with this. So that's what we want to do. So first thing we want to do is, since we're in Python, we're going to import pandas. This is and we're going to import it as PD because it short forms the work. So when we do this, this is a library that we're going to use called pandas, and then we short form it as PD. And so now every time we want to call in this library, we say PD dot whatever function that's available. So now we want to call in our file. So if we want to call in, for example, the CSV file, I want to call this in as what's called a data frame. So I'm going to call in this I'll do the CSV first. I'm going to call in the CSV file as a data frame. And the data frame is a tabular data set. So if you got a CSV, it's already a tabular data set. So if I double click on this, it's going to open up on the other side here. So we go here, and there's my data set. It actually shows me what my data set looks like. So it's a time series expanded. So we're going to directly get this in as a CSV file, just to show you the difference between that and a JSON file. So if I click on this, this is nested. So each one of these is a series of data from a specific time. In Toronto, this is the data from it. Here's the time. So we now gone from 0 minutes to, hours to 6 hours. And it's still Toronto, and then now we got Ottawa, we got Hamilton. This is a simple nested structure. This is one that can be called into tabular data fairly easily. I'll show you one that's more complicated. So this is a really good way of formulating data, large amounts of data. The problem is that it's more difficult to turn this into tabular data, which is what Excel and everyone wants to use. Excel does a phenomenal job of taking this stuff and turning it into tabular data. But we can see here now we've got two main things. One's called sensors, and then we've got readings that's nested. And then within the readings, now we've got that different structure of the different readings for different time periods. But now it can even be sub-nested based on the sensor. So sensor 1 is in Toronto, and these are all the readings for that subnested. Sensor 2 is in Ottawa, and then these are all the readings subnested. So it's a very easy way to read the data, but it's difficult sometimes to actually get this in, and we're going to see that when we go through this. So we're going to do our CSV file first, then we're going to do a simple JSON, then we're going to do the expanded, and we're going to suffer like you wouldn't believe. But overall, most data that you're going to find downloadable data is all going to be CSV files, and if we do a JSON file, we're going to try to convert it over. So now that I've imported pandas, I want to create the data frame. A short form for data frame as a variable is just df. You really should use a proper variable for this. So if I go enviro sensors, all right, and so that equals, so now I've got environmental sensors and I've got a data frame that's going to be sent to this variable. And so now to start that off, I'm going to say pd.read. And what'll happen now is Google Colab is starting to anticipate what I want to do. And I've got all these options. So I got CSV that I can read in Excel. There's the JSON, all sorts of different stuff. So I want CSV, and I'm just going to go like this. And so I got round brackets and I've got quotations. You can either do single quotations or double quotations. Either one works. Just make sure the beginning and end is the same. So what I want now is I'm going to copy this path like this. I'm going to put it right there. I'm going to Control V to get the entire file path in. There we go. And when I hit run on this, it's called it in. So now this variable contains this data frame. And so now nothing's showing up because I haven't told it to, but I can actually just ask it to do something with it. So now Enviro Sensors is now an actual, it's a variable that contains the data. So what do we want to do with this? I want to see what the information is on this. So this is going to give a readout, a general idea of what's in this data frame. So it's telling me there's 40 entries. It starts from index 0 to 39, but there's 40 data points that are in it. It has columns, date, time, location, temperature, PM 2.5, and humidity. The types of data, so object is a string. Object here is a string for location as well. It means it's type data most likely. Temperature is a float. That means it's a decimal. Integer is a whole number. So PM 2.5 and humidity are whole numbers. And so it's telling me this is what it looks like. We can also do what's called get the top 5 variables out of it. And so I can just do df head like this and like that. And so now it puts it into the tabular form, much like we would see with Excel. So now we know what we're dealing with. We've got a date, time, a location, temperature. Some of the things then that we want to do with this is we want to change some of the variables, maybe even the names. They're too long. So we could get rid of like the microgram per meter cubed and just put PM 2.5. There's a variety of things we can change. Also, this is considered a string, the date time. So if we wanted to plot this, these are not numbers right now. So we'd need to actually switch this column to a date time column. And now these actually turn into real dates. And we can actually plot this data versus time. So that's some of the things we want to do. But the fact is we've called it in. And I'm going to do another one here and just see what happens if I do enviro sensors. Yeah, see, it already knew what I wanted. So I'm going to describe. So this is going to give me some statistics. So anything that actually has numbers, so it should be temperature, PM 2.5, and humidity, should actually have some data. So there's 40 variables in each one of them. The average for each of these is given here, the standard deviation, minimum. So you can see we can do some really simple, basic stuff on this immediately using just very simple code. So let's try to call in the JSON file. And I'm actually going to get a bit of help from our AI. So I want to do this simple JSON. I'm going to copy path. And so when I go here to plus code, I'm going to ask Gemini right here, and I'm going to say, I want to read in this JSON file, and I'm going to put the specific file path as a pandas data frame, or just data frame is fine. I like to differentiate between Python and R. And so that's it. So let's see what it'll do for us. So it'll think a little bit. Like I said, we're learning a little bit about coding, but really we're learning how to use AI. So it looks like it's a very simple setup here. Let's see what happens if I run this. I'm going to just accept and run. And so when I call it in, I've now got a new variable called envirosensors.json, and it's read in this file. So now it's already telling me, like, what would you like to do next? And so I would like to see what the top 5 variables are. And so there we go. So we've now got a variable that's got a very simple setup. This was a JSON file. Just to take a look at it here again, this is what the JSON file looked like here. And so what it did was it took that JSON file and turned it into tabular data as a data frame. And now we can work on this overall. This data set is different, by the way, just so you know. One's got noise and soil moisture. This one's PM 2.5 and humidity. So let's try the nested one. So this one is a very, very heavily nested, and you'll see the difficulty that's associated with this one. So I'm going to just copy this path. And I'm going to ask for AI's help again. I would like to call in this heavily nested JSON file. I'm going to tell it what it is as a pandas data frame. And let's see what it does. Might take a bit more time to think about it. So since I told it that it's heavily nested already, it wants to do something new. It wants to import JSON, and it wants to use this file, this function called normalize. And so what happens is when we have these heavily, let's go back to this thing, when we have these heavily nested files, in order to get them into tabular data, it's called flattening. So I need to flatten this. If we were to just run it without this normalization, we would get this data to come out, but all these readings here would still be this nested JSON file within the table. So a table of data would contain all of this information, and another table column would contain all this and this. So it doesn't really help us at all. So let's see if this does the job. I'm not putting much into this right now. We'll see. So let's hit play, and you can see that it's already giving me an error. And so I can go through and explain the error. So it says it can't normalize, and it won't do it. So what I'm going to do is I'm going to just show you what happens. Let's go back up here. And so I'm just going to do the import JSON. So I'm going to go here, and I'm just going to I'm going to call this df JSON, and then equals read dot. And so instead of, I want to read in a JSON file, and I'm going to do this, and I want to get specifically the expanded one. I'm not sure if that one's got the correct one. So I'll put it here, Control V. All right, and so we're going to read this one in. All right, it says it's okay, so it's read it in. So let's see what this looks like, and I'll show you here. So dfjson.head, and we'll see this is going to give me the columns, and you'll see what's going on here. So it only gives me one column. In fact, let's just see the info here. The info gives you all the columns. dfjson.info already knows what I want here. So it's telling me there's actually only one column right there, and it's called sensors. So it did not flatten all of this data. So it's called sensors. And so if I go over to here like that, it's taken this as one column, and this is the data within the column. All of this is one data point. All of this is one data point. So you can see it can be more difficult sometimes with the JSON. It's a great way of actually getting the data in. Of storing the data, especially for sensor data out in the field, but to actually call it in can be very, very difficult. So there's a lot more work that's going to be required to do here. So what we're going to do is we're going to stick to the simple JSON. That's the easy one here, and work with that. If we ever need to do something like this, we're going to have to put in some more work and heavily rely on AI to help us out with that. It turns out that R is even more problematic when it comes to JSON. Excuse me. Um, so Excel can handle JSON data very well, really easily, and get the nesting flattened completely very, very easily. So if we do have heavily nested data, but not very much, I would recommend going to Excel first and flattening the data with that. Save it as a CSV file, and then pull it into Python or R. But if you've got very heavily nested data, Python can deal with it. R has a very difficult time, so we're going to try not to use JSON files for the rest of the semester. We'll just use CSV files. Pretty much everything that we're going to deal with is going to be CSV files anyway. We are going to show this in R though. We're going to go and take a look in R how to do this. All right, to use R, if we want to just use it natively in Colab, we can go to runtime, and we saw this before. I can change runtime, and I can go to R here. And if I do that, I can save this. And now we should see somewhere. I don't see it. Let's get rid of this. Typically, we'll get a runtime down on the bottom that just says R here. I'm not seeing that right now. But at this point, we actually can run R code. The problem is that there's no connection to Google Drive anymore, so we can't connect to Google Drive if we're using a runtime of R. What we have to do is upload files directly to our session. That's just meant that I had too many things up top here. And so that's problematic because if the session ever crashes, and it does happen to do that with R in Colab quite a bit, you're going to lose all the information. You have to upload it again every single time. We would prefer to work in Google Drive. So the workaround for that then is we use a runtime environment of Python, but we get a library up here that allows us to run in R. So I've got such a case over here. So what we do then is I can hook up to my Google Drive just like I've done before. So here I've got a connection in Google Drive. This environment, the entire environment is actually in Python. So if we look in the bottom corner, we'll see we're actually running Python 3. But the first thing we do is we run this library. So if we run %loadext and this library, this allows us now, anytime we use this %r, %r, everything underneath now becomes, we use R programming. So we just have to remember to use this every time. If we're using AI, AI will remind us about it if we tell it to. And so we can start downloading all our packages the exact same way that we did before. So I'm going to copy that, and let's start with a new file. So I just created a new notebook. I'm calling it Using R in Python, version 2, because I got one up here. And I want to connect to a runtime. It's probably going to tell me to manage sessions. I'm going to close all the other sessions. Oops. Okay, so I'm going to connect to our Google Drive here. It's going to give some time. There it is. I want to mount the drive. So remember, we're still working in Python. It shows us right down here. So we're still working in Python right now. And this is going to allow us to connect to our Google Drive using an R environment. It's Colab Notebooks, Environmental Sensing, Lab 3, and there's our files, like that. So I'm going to put this in, and I'm going to run it. So what this does here is it actually gets us to run the R package in Python. And so now it's ready to go. And so now I can ask this to import the CSV file. So I want to import this one. And so I'm going to use AI to help me out with this. I'm like using R code, read in this CSV file as an R data frame. So I'm going to specifically call it an R data frame because the coding is different. And so we sit and wait a little bit here. And so it's telling me here, so it gave me the %R, so that tells me that it's going to run this as an R file, whatever comes underneath. And you can see the difference. So instead of data frame equals read underscore CSV, it's got this character instead. So R is slightly different. And so the terminology is still the same, like print the head of the data frame. So you can see in Python it was very similar as well. So I'm going to accept and run this. And there it is. It just has the CSV. So now all the information is in here quite easily. And we'll see as we're going along, part of the reason why we like to use Colab is it actually starts to figure out what we're going to do next. And you can see it gives a lot of options for us right now that helps along the way. So we can check the structure and data types of the data frame columns, which is very useful. We want to know, like, is this actually date time or is this a string? What about these ones? Are these all any missing values, that kind of stuff? But what we did with the previous one, so with this data wrangling, we did a simple descriptive statistics just with one line. I'm going to show you it's just as easy to do it here. So if we ask this and just say I want a summary statistics for the data frame using R, it'll go through. And so using %% summary data frames, if I click on this, there it is. And so you can decide which one you think is the better one. So it still went through the date, time, and the location and tried to do some values out of that. There is some information that is worthwhile. So the length of this is there's 40 units and there's 40 units here. There's 10 unique values in the date time. There's 4 unique values in the location. So there is some information more that comes out. I don't think the table is as nice. So if we take a look here, this is the table here that comes out, and there's a bit more information. So we got the count, the mean, standard deviation, minimum, maximum, and we have all the quartiles that are involved. And when we go here, we do see there's quartiles as well. So first quartile, median, mean, third quartile, and then there's a max. So the same information overall. And so it works. So I'm going to accept and run. And there we go. So we've now got our pandas data frame, sorry, our data frame into this variable called data frame, and we can now manipulate it using our programming language. All right, so let's try the JSON and see what if we have any issues with that. So for example, this is the simple data frame. So read in this JSON file into an R data frame. And let's see what it does. So with the Python, it was much more straightforward for doing it because it wasn't heavily nested. And we'll see what this does. So it's telling us now we need to put in some more libraries. So we loaded this one here, and then we're going to say load in the data frame, and we're going to print the head. And it worked, right? So for a simple JSON file, it was fairly easy. It actually did the same work that the Python one did. So if we'll take a look, we'll see the order of these events here. And so with the simple data frame here, it did the same thing, Toronto, Toronto, Ottawa, Ottawa. And so let's see here, Toronto, Toronto, Ottawa, Ottawa. So it's the exact same outcome. But let's go to this, or accept and run. Let's go to this heavily nested one and see the issue with this. So I would like to read in this heavily nested JSON file into an R data frame. And we'll see how complicated this gets. I don't think I've ever really been able to get this one to work. But giving it explicit instructions helps out. So it's telling me to do the same thing. All right, so same as this simple one. So let's go and run this. And you'll see here the exact same problem. So it's telling me that I've got one column called sensors. And so I've got this information here called sensors S1, 2, 3, 4. It looks like I've got another column called readings, and all of this data is underneath it now, and possibly another column. I'm not really sure. But you can see that the data is not useful here at all. The date time stuff has just not been separated. And if I wanted to, I could try to ask it to flatten it more. So I'll just accept and run, and I'll just tell it that the data is not flattened properly, and I would need to specify what needs to. It looks like the readings section is still nested, and we'll see what it can do. So right here it says it's read the heavily nested into an R data frame with this. With the flatten equals true to handle the nested structure, this will flatten it. Wow, look at that. So it's very complicated. It's calling in another library, two different libraries here. It's going to look at each one of these different things, location, latitude, longitude, and we'll see what this does. I don't have any hope of this, but let's just try it. And so when we click on this, we'll see we got the red symbol there, which tells me there's an error, and we see we got an error. And so instead of beating our head over this and trying to figure it out, the fact is that the Excel file worked much easier. And just as a reminder for it, here is the Excel file, and you can see what it pulled in. So this is what it was able to do with the JSON file. So much easier. There's the 4 sensors, there's the actual city tied to it, and then all the readings. So this is tabular data. It's forced into this structure. There's a lot of repetition. Like for example here, every time it says Toronto, sensor 1, the location, all of this is repeated data. And so what the JSON does is it allows you to reduce some of this repetition. So the file can technically be a little smaller, but to deconvolute it, it's much more difficult. But again, suggestion is if you do have a heavily nested JSON file, maybe bring it into Excel first, try it in Python, but don't bother with R. It just causes havoc.